All right, 2-1B at-home practice problems. You can see here it asks us to graph the linear equations by providing at least 3 ordered pairs on a table. You can do this by points as well. And then graph the line on the grid. So we're going to look at y equals negative x plus 6. So what I've done here, let me make that a little bit bigger. I have got y equals negative x plus 6 on this Word document. And so we're going to pick some points, and we're going to pick some, I should say, x values, and find the points that work in this line. So generally speaking, let's pick some x values like -2, -1. I'll pick 0, 1, and 2. Okay? You could pick 3 as well if you'd like. Okay? Pick whatever you want, but these are the x values that I'm going to pick. Now, in order to get each corresponding y value, so if I picked an x value of -2, what I'm going to do is I'm going to plot y equals negative, plug in -2 plus 6, and then evaluate that. So if you do that, you plug in -2 into this equation, what you get out is the equation that says y equals 8. So when x is -2, y is 8. All right. Now, I don't know why one of those is bold, but there we go. Let's do both of them bold. There we go. So -2, 8 is a point on the graph of this line. I go down to -1. I plug in -1 into my equation. Y equals 7 is the answer. So y equals 7. When you plug in 0 into the equation, plug in 0. Y equals 6 is the answer there. Again, each time I'm just replacing the x value with the number that I've plugged in here. So 6. When you plug in 1, you'll see the pattern come up. Y is 5. So I put 1, 5. When I plug in 2, you get 4. And when you plug in 3 in for the x value, you end up with 3 as the y value. Now, one thing to be a little bit careful of, just be real careful of this negative sign. Some people, when they start plugging things in, forget to write that. But what I have here is a bunch of ordered pairs. Probably don't need 6. Probably could have gone with less than that. The question itself asks for just 3 at least. But once I get these points, then I'm going to plot them on the graph. I'm going to, once again, use the graph paper. So what color do we want here? Let me do this in blue. So what's the, go back, -2, 8, -1, 7, 0, 6, 1, 5, 2, 4, and 3, 3. So what we're going to do is we're going to plot -2, 8, 1, 2, 3, 4, 5, 6, 7, 8 is there. -1, 7 is there. 0, 6, 1, 5, 2, 4, and then 3, 3. So this shows the pattern of points. And then obviously, if we want to create a line or something like that, we can just create the line. I'm going to try to do this by connecting those dots. and saying that that pattern extends forever. So in order to say that pattern extends forever, we just put little arrows on the end. Again, this is not done real neat because I'm trying to use my computer to do that, but that's it. So that's our line y, that's the graph of the line y equals negative x plus 6. Next line it has us do, it has us graph is y equals 2x plus 7. Again, we're going to graph this using the table method. And so what we do is we take a look, y equals 2x plus 7. We're going to plug in different values for x. Now it doesn't matter exactly which values you pick. I'm going to pick the same, negative 2, negative 1, 0, 1, 2. Obviously, some of these could end up off our grid. That's perfectly fine. So let's plug in negative 2 for x. If I do that, I get y equals 3. Excuse me, y equals 3. If I plug in negative 1 for x, I end up with y equals 5. If I plug in 0 for x, I end up with y equals 7. Again, I'm doing this very quickly because we've done this a number of times in class before. When I plug in 1, I end up with 9. So the point 19 is on the graph. And if I plug in 2, I end up with a y equals 11. So if I plug in 2 for x, 2 times 2 plus 7 is 11, so y equals 11. So I have these 5 ordered pairs, these 5 points that I can plot. So let's do negative 2, 3, negative 1, 5, 0, 7, 1, 9, and 2, 11. We'll plot those on the same grid, something like we did before. So negative 2, 3 was my first point. It's right there. Negative 1, 5 is my second point. It's right there. 0, 7 is my third point, which is right 7. I got to count right there. Then 1, 9. And then you'll notice that 2, 11 is off my grid. I'm not even going to write that point because it's off my grid. And then if I'm going to make a line, obviously we just connect those dots and say that the pattern goes on forever. So we connect these dots, and then in order to symbolize that the pattern goes on forever, we just draw an arrow at both ends of this line. So that is the line. Again, it would be a little bit better if I could freehand this and not use my mouse, but that's the line y equals 2x plus 7. All right, y equals 2x plus 7. That's the graph of that line. All right, next line here is 3x plus y equals 4. Now in this situation, 3x plus y equals 4, that's not actually solved for y like the first two were. So I'm going to solve this for y. I'm going to get this into what we see in section 2.2 is slope-intercept form. So I'm going to subtract 3x from both sides. When you subtract 3x from both sides, you get y equals, well, minus 3x plus 4. Hopefully that all makes sense. All I'm doing is I'm just taking subtract 3x from that side, subtract 3x from this side. By the way, again, I'm trying to use my mouse, so everything's not quite as nice as it would be otherwise. So I'm doing that kind of a thing. On the left, the 3x gets canceled out. On the right, 4 and minus 3x are not like terms. So when I subtract them, I'm just going to write minus 3x plus 4. I can't combine these because they're not alike. So once that's done, what I can do is I can start plugging in various values for x. It makes my life a little bit easier to put the equation in this form. You don't have to, but it's a little bit easier. So what I'm going to do is I'm going to plug in the same values for x I had, -2, -1, 0, 1, 2. You don't have to use those. I keep reiterating, but I'm going to use those just because they're kind of nice and standard. So if I plug in a -2, be careful of the negative times negative, gives me a positive. You end up, with y equals 10. So plug in -2, you get a y value of 10. If I plug in -1, I end up with a y value of 7. If you plug in 0, you end up with a y value of 4. If you plug in 1, you end up with a y value of 1. And then if you plug in a 2, you end up with a y value of -2. All right, -3 times 2 is -6, plus 4 is -2. So that's what we end up with. We end up with the points -2, 10, -1, 7, 0, 4, 1, 1, and 2, -2. Now, when you go to plot this line, I'll plot this one in this pink color, darker pink. So -2, 10, that's actually at the very top here. Let me make that a little bit thicker. Maybe not that thick. So -2, 10. My grid only goes up to 10, but that's okay. -1, 7. 1, 2, 3, 4, 5, 6, 7. Looks good. 0, 4. 0, 1, 2, 3, 4. 1, 1. That one's nice. And then 2, -2. So now we've established the pattern. Again, if you don't want to use this very top one, that's fine. And now I can just draw the line and let's see if I have a straight line. I don't think I do have a straight line. So I could draw something like this. That's that line. Good. And then I guess I drew that in black. Not a huge deal. Just to symbolize that this goes on forever. Arrows at the top, arrows at the bottom. There we go. Okay. So that is the line, that is the graph, excuse me, of the line 3x plus y equals 4. So that is how you create a table, fill out, get a table of values, which gives you a bunch of points, plot the points, and then once you've plotted the points, get the pattern by drawing a straight line. All right, so that is the end of 2-1B at-home practice problems.